Kim, there's been a lot of attention given and concern over, and rightfully so, the type of voids that occur in the bottom termination components, BTCs, particularly in the ground plane. But the voids that also very much so keep us awake at night are the voids that occur in the actual solder joints, the electrical interconnections. What are some of those voids?
You're absolutely correct, Phil. Often we talk about how to avoid the void when it comes to bottom termination components such as QFNs, but sometimes we need to focus a little bit more on the other types of voiding. First type of voiding being Kirkendall voids, which are often called champagne voids. They occur along the intermetallic layer on the pad side, and they can affect the reliability of the solder joint as the intermetallic layer is the weakest part of the joint. Those little extra voids in there allow the crack to propagate even more so. They're called champagne voids because they're actually, they look like little champagne bubbles inside the solder joint.
They're very small, but they can be very nasty, as you said.
Absolutely.
Right case. What other types of voids should we be concerned about?
So another type of voiding would be shrinkage voiding, which happens often on off-eutectic solders. So what happens is some of the particles in the solder joint are expanding or contracting under heating and cooling, quicker than others, quicker or slower than others. So when that happens, you're creating little pockets within the solder joint, and usually to remedy that, you'd want to use a eutectic solder instead, and that helps to have it so all the particles are expanding and contracting at the same rate under heat.
Okay. How about our old nemesis, the VN pad?
A VN pad, right? This happens a lot on BGAs. So when the flux is outgassing, it gets caught up in that via and it creates a void.
And of course, with the pitches of area arrays, BGAs, CSPs, flip chips getting finer and finer, down to 0.4 millimeter pitch, going down to 0.3 millimeter pitch, there's obviously less room for the designer to fan out in the dog bone pattern. So he's going to go with that old VN pad.
Yep, exactly. Yeah. Yep, so you got to watch out for that sometimes.
Sure do.
Yep.
You sure do.
And the last type of voiding is blowhole voiding that occurs during wave soldering when the solvent isn't completely evaporated in the flux and it pools up in the holes, and when the hot solder hits it, it explodes and creates a void.
Kim, when we talk about voids, the other concern we have, is it a defect or is it only a symptom? And that's going to basically guide us in action whether we're going to do rework or it's cosmetic and we should just basically, as best practices, leave it alone. How do we determine that?
Once the board goes through X-ray analysis and the operator may see something a little weird that may need further analysis, you would take a cross-section of the solder joint, which is a destructive test to investigate the proximity of the void to the interface of the solder joint.
Kim, where can we find out more information on this topic?
So you can go to our website at www.indium.com, or you can email me directly at kflanagan@indium.com.
Kim, thank you so much.
Thanks, Phil. Nice talking to you.
Pleasure.